Welcome back, everyone, to today's explainer. Man, if you build command line tools, you are absolutely going to want to stick around for this one. We're unpacking this really great micro case study from a developer named Ang. Specifically, we're looking at part 143 of his Notes on Haskell Programming from May 23rd, 2026. He ran into this tiny little issue, but it actually has massive user experience implications. And honestly, his solution is just a perfect example of using the exact right tool for the job. So let's explore how we can dramatically level up our terminal applications. Okay, let's dive into this because, let's be real, we've all been there, right? You're deep in the zone, flying through your terminal, you type a command, hit space, type the first letter of a file, and instinctively mash that tab key, fully expecting the rest of the file name to just magically appear. But instead, absolutely nothing. Just that mocking little terminal bell sound. It's so annoying. It is a universally frustrating experience when a command line tool just completely refuses to help you finish your thought. Which brings us to Section 1, the missing autocomplete. So here's the setup. Ang was right in the middle of testing this brand new console app he created, which he called XS2 ebook. Now, his expectation, and really the expectation of any modern developer, was instant completion for his text files. I mean, that's just standard command line behavior these days, right? But the reality? His new XS2 ebook application was completely unresponsive. No matter how many times he tapped that tab key, the app stubbornly refused to fill in the file name. It really forces you to stop and ask, wait, why is standard out-of-the-box functionality completely broken in my app? Let's look at Section 2, the Haskell code fix. What Ang quickly discovered is that terminal autocomplete isn't just, magic. It doesn't just happen by default the second you compile a program. It's actually a very precise feature that needs to be explicitly unlocked and defined. For his Haskell application, that master key turned out to be a specific library called optparse-applicative. This library is absolutely crucial. It provides the underlying infrastructure you need to parse command line options and actually map out the inputs your application expects. Because think about it. Without it, the shell environment literally has no idea what your application wants. And if it doesn't know what it wants, it can't possibly guess what to autocomplete. And this brilliantly illustrates how a massive user experience upgrade can sometimes require the absolute tiniest bit of code. Just look at this. By explicitly defining the arg parser as parser args and mapping it to args, Ang created the exact key he needed. That's literally the whole def. By bringing in that optparse-applicative library and adding this one small parser modification, he completely unblocked the entire feature. It's just a wonderful reminder that in structured programming, sometimes the simplest changes yield the absolute most powerful results. Moving right along to Section 3, generating the script. Okay, I want to methodically walk you through Ang's exact workflow here. Let's slow down for a second so we can really appreciate this pipeline, going from Haskell logic all the way to bash execution. First, as we literally just saw, step 1 is adding that precise parser code to the Haskell source. Step 2 requires us to actually compile the XS2 ebook console app. This ensures that the new optparse-applicative logic is baked directly into the executable itself. But step 3? Well, step 3 is where the real magic happens. We aren't writing a bash script by hand here. Instead, we run a specific generation command to let the application do all the heavy lifting for us. Check out this exact terminal command right here. By running xs to ebook -- bash completion script xs to ebook, we tap into something conceptually brilliant. Because of that parser code we added back in step 1, the newly compiled xs to ebook app now has the inherent built-in power to write its own completion script. It basically introspects its own required arguments, understands its own internal structure, and outputs a script that your bash terminal can natively understand. You are essentially asking your app to explain to the terminal exactly how to interact with it. How cool is that? Now, what's really interesting about this slide is the actual generated bash output we get. And don't worry, you don't have to be some bash scripting wizard to appreciate what's happening here. It perfectly sets up local variables, securely defines the command line string, and handles the completion index using standard bash variables like comp cword. But pay special attention to that final line down there, complete-o file names. The Haskell optparse-applicative library automatically mapped out this logic. It inherently knew that the app needed file names, and it constructed a perfectly formatted bash function for it. This entirely saved Ang from having to sit there and debug a highly error-prone shell script manually. Let's wrap up with Section 4, the essential CLI feature. Zooming out a bit from the X2 EasyBook project, Ang summarizes this broader philosophy perfectly. He says, such features should be the essential for any CLI library, especially those part of the standard library. The absolutely crucial point here is that autocomplete isn't just some luxury. It's not an afterthought that you tack on at the end if you happen to have some spare time. It is a foundational standard of modern computing. If you're building a tool that's meant to be used in a terminal, giving your users the ability to press tab and instantly get what they need is just fundamental, respectful design. It saves time, it prevents super annoying typos, and honestly, it just makes your software a genuine joy to use. Which leads us to a pretty vital question for you to take away today. Is your CLI tool up to the standard? When a user, or hey, even you 6 months from now, mashes that tab key on the command line interface you built, are they greeted with helpful context-aware completion? Or are they met with that frustrating, empty silence we talked about at the beginning? As you go back to your own code bases, I really challenge you to implement these standards. Leverage powerful tools like Haskell's optparse-applicative to build better, much more responsive applications that actually respect your users' time. Thanks so much for hanging out with me for this explainer. I really hope this sparks some cool ideas for your next project, and I cannot wait to explore more fascinating topics with you next time.